Good morning, good evening, everyone. Today we are going to discuss a paper about powerful model for document classification, hierarchical attention networks for document classification. So what exactly is classification? It is one of the most fundamental and widely used tasks in natural language processing. The main goal is simple, to teach a machine how to read a piece of text and automatically assign a predefined label or category to it. So, examples, topic labeling, sentiment classification, spam detection. These are the existing methods that were discussed as baseline in this paper. They can be grouped into three main categories. On the left, we have linear and SVM models. So these are traditional methods. So first, back of words, back of engrams. So these are more traditional approaches. So it is a straightforward method that simply count the frequency of words or short phrases. Next, bag of means. So it is bit more advanced. It represents the entire document by averaging the pre-trained word to vectors. So next, SVM plus text features. So it relies on manually engineered features like engrams and sentiment lexicons to work effectively. The main takeaway here is these methods rely on statistical features and often ignore the word order and context. So next we have standard neural networks. So first word character CNN. This applies convolution neural networks, which is in image processing directly to text. They are effective at learning features and from sequence of words and individual phrases. So next we have LSTM layers. So you already know that these LSTM layers are used for process sequences. Next we have hierarchical models. So these methods are more aligned with the proposed method. So these are the state of art at that time. What is the core idea behind hierarchical attention network or HAN? It builds on two very simple and intuitive concepts about how we understand documents. The first is hierarchical structure. As this diagram shows, first words followed by sentences, sentences followed by the entire document. The hand model is specifically designed to mirror this structure, first building an understanding of each sentence and then aggregating that to understand the entire document. The second and most important intuition is the attention mechanism. For example, when we are reading, so we don't give every single words equal weight. So here also the same. For in this example, you can see the words like long, perfect are given more attention. So it is more crucial to understand the sentiment of this review. So just like a human reader, when we also are reading some article, we tend to highlight some sentences, some words. So here also the model is trying to mimic the same behavior. Let's walk through the model architecture. So I have identified two components in this model. First one is word to sentences and next one is sentences to documents. So they are it consists with encoder and the attention module. So in the both scenarios, it is same. So it is encoder and the attention mechanism. So in encoder, they have used bidirectional GRH. So they have used bidirectional. So to get the information from the both the direction in the forward and the backward direction. In the attention, they have used single layer perception attention mechanism. To understand more about this model, so I have added a pseudocode here. So the function is here, so hierarchical attention network. So it inputs the entire document. So the first step is to split the document into sentences. So here you can see for loop, each and every sentence is passed through the word encoder and the word attention. So it outputs the sentence vectors S1, S2, SZ. So these sentence vectors are passed through the sentence encoder and the sentence attention and produce the document vector V. So this vector is used for the classification. So if I explain more about that, so here W21 is the second word, second sentence, first word. So W22 means second sentence, second word. So these H vectors are in the paper they call it as annotations. So let me explain how the attention and the encoder part works. So here in this previous slide I said that so these are annotations. So these are forward hidden states. So these are backward is hidden states. So combination of those two here you can see concatenation operation. So combination of forward and the backward states. So we call it as a one annotation. So here this is a word annotation. Here it is a sentence annotation. So then the attention mechanism. So these U and alpha are learnable parameters. So these are learned by the dataset. So here what they are doing is, so they are multiplying those annotations with those alpha vectors and output the attention out. Next, high model comparison of hierarchical networks. To really prove the attention mechanism was the key ingredient, so the authors compared three different variations of their hierarchical network model. So the first on the left we have hierarchical network with the attention. The main model we are discussing. So next we have hierarchical network with average. So so instead of complex attention mechanism, so it simply average all the word and sentence annotations. This is equivalent to an attention model where every word gets the same weight. While it couldn't beat the main model, but its stable and solid performance still shows that just using hierarchical structure is beneficial. So finally on the right we have hierarchical network with max pooling. This method selects only the single most prominent feature from the annotations. This method is less effective than other two. Next, dataset. To prove its effectiveness, the hierarchical attention network was evaluated across 6 large-scale datasets, which cover two NLP tasks: sentiment classification and topic classification. The table on the bottom gives you a sense of the scale and variety of the data. So here S means the here the here S means number of sentences. So W means the word. So here average number of sentences, maximum number of sentences, and average number of words and maximum number of words within one record. So here you can see these data sets are in the are in millions. So in the IMDb review dataset has average 14 sentences in one review. So in the Amazon review dataset only has around 5 sentences in one review. So by evaluating the model on such a diverse and large scale datasets, the authors could confidently demonstrate its robustness and general applicability to different document classification challenges. Now let's briefly go over the technical details. First, the data preparation. They built their vocabulary filtered out rare words. The initial word vectors were generated using 200-dimensional word-to-vec embeddings. So in the model specification, they have used 15 GRU units. So since it is a bidirectional model, this results in 100-dimensional vectors for both word and sentence annotations. So in the training process, they have used stochastic gradient descent with batch size of 64. So they have used a clever trick by grouping documents of similar length together. They were able to speed up the training process by 3 times. Finally, to ensure they are using best possible settings, they found the optimal learning rate through a grid search on the validation set. Now the exciting part, the results. As you can clearly see, hierarchical network with attention has state-of-art performance in all those datasets. In the L15 dataset, it improves over 3%. So in IMDb dataset, it improves over 4%. This quantitative research is a strong confirmation of the paper's hypothesis, modeling the hierarchical structure of documents and using attention to find important content leads to a superior model. So we have seen that the model works well. But why? This diagram gives us an insight in what the attention mechanism is actually learning. This is how the attention is given to the word good across different star ratings. So in the first chart, we can see the entire attention to the word good. So the first one is 1 star rating, it is a bad sentiment. So in that scenario, the word good is given lower tension. So it is cut usually. So because in these scenarios, the word good can be in the context like not good. So in that scenarios, the model tries ignore the word good. So in the 2 star rating, also the same. So here 3, 4, 5. So the peak of the distribution steadily shifted to the right. This proves that the model just memorizing the list of good and bad words, it is learning the importance of word based on the context it appears in, which is much more sophisticated and powerful approach to understand the language. Let's zoom in further how model works. This slide shows 2 examples from Yelp dataset. The first one is a 5 star rating. The words like delicious, amazing are given high attention. At the same time, scalpless. I don't even like. If we consider this sentence as an individual, so it is a negative. But these kind of sentences are given low attention, 5 star rating. So here it is a negative sentiment. It is a 1 star rating. So words like terrible will not go are given high attention. At the same time, here you can see the word good. So this sentence is given low attention. So these examples clearly show the model is capable of understanding nuance, sentence level and document level context to make a very accurate classification. While the hierarchical attention is powerful and accurate state of art resource, it is important us to consider its practical limitations, especially when thinking about deploying it in real-world systems. First, there's a challenge with adding a new categories. The model's output layer is fixed. The number of classes are fixed to the number of classes it was trained on. So if we need to add a new category, we have to retrain the entire model. So this is not a good practice in agile workflows where we need to adapt quickly. So second, compute this is computationally intensive because they are using GRUs as well as attention mechanism. So this require larger data sets. So this is data hungry. The paper demonstrates its strength on very large data sets. If you only have a small amount of training data, a simple model might actually perform better, as a complex models like hand would overfit and fails to generalize well. To wrap up, we explored how the hierarchical attention networks acts much like system you can see, intelligently sorting and understanding documents. Thank you very much for your time and attention.